example B. We want to identify the center, radius, and diameter of the circle with the equation, the given equation. So we're working backwards from what we did on example A. I already have the equation. I need to go back and find the center and the radius. I know that the standard form is x minus h squared plus y minus k squared equals r squared, right? So that being said, my h is obviously the 7, my k is the 3, and my r squared is 64. So my center, which is the h and the k, I just said was 7 and 3. And then the radius, if r squared is 64, then r squared is 64, then to find r by itself, I would simply take the square root, and the square root of 64 is 8. So my radius is 8. All right? Let's look back at this equation. I had a minus 7 in there, but my center was a positive 7. I had a minus 3, but my coordinate was a positive 3. You notice that they're opposites. They're the opposite of what you see. It's the opposite x and the opposite y. The opposite of what you see in the formula, and that is because, well, what you see in the parentheses, and that is because the formula has the subtraction sign to begin with. So you could just say to yourself, my center, on example 2, my center is just going to be the opposite x and the opposite y. It's going to be the opposite of what I see in the parentheses. So my center is 4 and negative 10. It's the opposite of what I see. The h was what was taken away from the x. The k is what was taken away from the y. But because this is a plus, that means that it was a minus and negative like it was on example A. So your center is always going to be the opposite of what you see in the parentheses in your standard form. The opposite x, the opposite y. All right? Your radius, of course, this last number is always your r squared according to our standard form. If that's my r squared, then what is r? If r squared is 15, then I just take the square root. R, the radius by itself, is the square root of 15. That does not turn into a pretty whole number, so I just leave it as it is. It does not simplify. The calculator will do it for you, but some don't. So remember when we broke down our square roots? Like this is a 5 times a 3, and I was looking for a pair of 2 to pull out. So that's what I mean when I say that it does not simplify. There's no two numbers that are alike to pull out here. Okay, number 3. My center is going to be opposite x, opposite y. If I just do that, my center would be negative 3 and a positive 9. That's my opposite x, opposite y. That is my center. My radius is just going to be, this is the radius squared. So if r squared is 48, I just want to take the square root to get r alone. Now the square root of 48 does simplify. It does simplify. The square root of 48 is a 16 times a 3. That's a 4 and a 4 times a 3. Or again, your calculator might do this for you. Oh, by the way, number 4 is a star. But I need the space now. So the 4s would come out, the 3 would stay in, and you could continue breaking it down to the 2's if you want, but my simplified version of my radius would be a 4 and the square root of 3. That's what I want. I want the simplified version. If it can reduce, well, not reduce, it's not a fraction, but if it can be simplified, then I want you to do that for the radius. I'm just realizing I forgot the diameter. Now, what do we know about the radius and the diameter? We know in a circle, if this was my center, my h and my k, my radius is just a line segment that goes from the center to a point on the circle, and the diameter was all the way across, right? The diameter was all the way across. The diameter was 2 of the r's. Your diameter is 2 of my radius. my radii, 2 radii. So if I wanted the diameter, I would simply take whatever number I had for the radius and multiply it by 2, right? So on B1, my diameter would be 16. On B2, my diameter would be 2 times the square root of 15. Remember, those don't play together. They're not both inside the house. I have 2 square root of 15s. And on 3, my diameter would be 2 times that 4 in the square root of 3, which would give me 8 in the square root of 3. My diameter here would be 8 in the square root of 3. The 2 can multiply with the 4 because they're both outside of the radical. Okay, that is example B.